So in this video, we're going to look at our transformations of curves, the dilation, the stretch, and the translation. And we're going to see if we can find out where points go to if we don't know what the function is. So I've got a function fx, and I don't know what it is. But I've got 2 points on this function that I'm going to move or transform onto this new function gx, and it's 2 times f to the minus x plus 3. So I'm going to do this green one first of all. Now I'm going to think about the x coordinate 2, and the only thing I'm doing to it is making it negative x. Now in fact I'm just going to make it negative x, but that's not really the explanation. We are reflecting that in the line x equals 0. So when we reflect 2, it's going to go to minus 2. That's the only thing we're doing to the x coordinate. The 2 and the 3 are vertical transformations. So I'm going to take the minus 1 and I'm going to multiply it by 2 to get minus 2. And then I'm going to add 3 on. Minus 2 add 3 is 1. So I think that first one transforms to minus 2, 1. Do you want to pause the video now and try the 4, 3? So the 4, 3, that goes to negative 4 because we're reflecting it. We take the 3, we multiply it by 2 to get 6. We add 3 on to get 9. So I'm going to check that on the graph. We'll just show you graphically what's happened. So if I go into my Desmos, we can see here that the 2 minus 1 has been transformed to give me minus 2, 1. And the 4, 3 has gone to negative 4, 9, as predicted. Let's do another one. Let's do hx. Let's do the green one first of all. And I'll do the 2 minus 1, and you can try the 4, 3. So for this, in the bracket here, I've taken the x coordinate, and I've done this transformation by multiplying by half. Now don't just take the 2 and multiply it by half. The half means I stretch it or dilate it by 2 units, not a half. So I'm going to take that 2 and I'm going to make it 4. And then it says take away 1. So when I take away, it moves it to the right. Now a funny thing is happening here. The instinct would be to multiply it by 2 and then take away or add 1 rather, making it 5. But it's not quite as simple as that. This half here, the times in by 2, is doing a funny thing to the whole dilation. So the whole transformation. It's turning it to 4, but this is also affecting this. So it's actually moving it to the right by 2 units. So we've times it by 2 to get 4, and then we're going to move it across to the right by 2 units, so it turns it into 6. That's quite a complicated one to get hold of. Now the vertical translation, the minus 1, that's straightforward. We're just timesing by 3. So this should just time to get minus 3. Okay. I'll pause, you can try the red one, and we'll have a look at graphically and see if we've got those correct answers. Okay, so the red one now, the 4, 3. So the 4 gets multiplied by 2 to give me 8. And then when I take away this 1, I'm actually taking away 2, or I'm adding 2 onto both sides, so that 8 becomes a 10. That's the complicated one, so a couple of things to be aware of. And then the 3, that's dead simple. The 3 is just being multiplied by the 3, so we should get 10, 9. So let's hope that we get 6 minus 3 and 10, 9 when we do this. So graphically, got it on here. There's my curve. There's that vertex in the same place, and that 4, 3 is also at 10, 9. So just a couple of things to be aware of there is what's happening to that 6 and that 10 when we are multiplying by 2, and then not just moving it by 1, but moving it by 2 units because of that times in by half.